This is our fourth video on electricity calculations, so we're near the bottom of page 3 and we'll finish off page 4 as well in this video. So here we go, we've done those combo specials. We can also link Ohm's law, which is the V equals I times R, and the PIV formula, P equals I times V. So if P equals IV, V equals I times R, well, if I just substitute this in here, IR where I had a V, I get I squared R. And again, this is not a formula you have to memorize. Just use it as a tool. You'll have the formulas. All right, we're told we have 2.8 kilowatt hours of energy consumed in 3 days by a device plugged into a 120 volt circuit. Calculate the device's resistance. So we're going to be using this. What have we got? Well, we've got to do a little funking. We're going to need to get power, and we've got our energy, and we've got our time, so that lets us get our power. And then once we have power and voltage, we are going to be off the races for getting the resistance. So first of all, we write P equals E divided by T. 2 kilowatt hours divided by 72 hours. So I just left this in kilowatt hours. And I made 3 days, 72 hours, because I just go 3 times 24 hours every day. From this, I get 0.0389 kilowatts, or 38.9 watts. So now I have a power. I do have a power. I have a voltage here, and power divided by voltage is going to equal my current. And I get my 0.324 amps, like that, or 324 milliamps. Other ways of tackling it are R equals V divided by I. Well, we've got to get that resistance. So we take our voltage, and that voltage is still 120 volts, and we divide by 0.324 amps that we just calculated. And now we go back to the question, it wants the device's resistance, and we get 370 ohms. Now let's see what we got below here. There's another OR way. So this really was a combo special. We were using 3 different formulas, but we can be a little more elegant. Now, R equals V divided by I equals P divided by V, and so then we can have our V divided by P divided by V. So we're going to get a V squared out of this deal, V squared divided by P. Well, look at this. Here's our voltage. We calculated our power somewhere here, and we can do it very quickly this way. So if we take 120 volts, if we take that power we calculated earlier, we get 370 ohms. So it doesn't matter which way you like to do it. Either way is fine. This formula, R equals V squared divided by P, will be given on your sheet of formulas. These are tough questions, and so just do your best. They do take practice, and you will get worksheets that give you that practice. Now, it says, what's the energy consumed in 1 week by a light with a resistance of 80 ohms plugged into a 120 volt circuit? So we know energy equals power times time. So that means really what we need to do is find the power. Now, I equals V divided by R. So we have our voltage, we have our resistance, we get 1.5 amps. That's going to be handy. We know power is current times voltage, so here's our power, here's our voltage, and we get 180 watts, which is 0.18 kilowatts. And since we're going to be doing a week, that's going to be a lot of time. That's why I went to kilowatts. Way back when, we said energy equals power times time. So we take that 0.18 kilowatts, we multiply by the number of hours in a week, which is 168, and we get 30.24 kilowatt hours. So again, combo special, we had to use 3 formulas to get there. There's a lot going on there. Another way, if this thing will move, is somewhere here. I equals V divided by R, so that hasn't changed. And P equals I times V. Well, what do we see? Well, we have a V divided by R that we can substitute in there, and we have a V there. So V over R times V is V squared divided by R. So many students don't necessarily understand how this formula came about, but it often makes it easier for them. So we know what the current was, and we know what the voltage is. So we can get our resistance, and we are off to the races. So here we are, 120 volts squared, that's our V squared. Our resistance was given in the question, 80 ohms, and you let the calculator do the work, and it comes out to 30.24 kilowatt hours ultimately. Again, this is a way of getting the power, so we can put it in the PET formula. Yes, tricky. You may want to watch the video a number of times just to see the steps, and make sure you have your video sheet handy, not video sheet, formula sheet handy.